Perfect. Okay, for those of you watching at home, I hope is that recording?
Yeah.
Okay. For those of you watching at home, hi. This is Monday. We're going through the second practice test. Take it out, everybody. Let's see what we've got. Got it. I'm going to rip through the answers here in just a second. Grab your red writing utensil. And the vast majority of the hour we're just going to spend going through any answers and questions we have on those. And then the test is tomorrow. Just so everybody's aware of the schedule this week. Wednesday, y'all are going to be stolen from me because of household day. So what I'm planning to do, we're having a test tomorrow. Wednesday is no class. Thursday we're going over the test. Since we're up against the wall, as far as this test goes, next week is finals. So here's what I'm planning to do. Friday, I am going to dedicate as being a retake day for this chapter test, in case anyone needs one. If you do not need to retake the test that we're going to be taking tomorrow, then you can bring something silent to work on for the entire hour. Next week, starting on Monday, I'm going to give you a practice final. We'll take it in class. Tuesday, we go over the practice final, and then the real final is on Thursday. Does that make sense? Yeah.
If we aren't retaking the test on Friday, can we maybe get the practice final on Friday?
Oh, well.
Or just like some big concepts?
Let
Or your
me think about that. Let me think about that. That's a possibility. I'll tell you by the end of the hour. All right. Number one on the practice test. Fundamental theorem of algebra is D. A polynomial's degree equals its total number of roots. Number two. What result would come from the rational root theorem? Choice A. Possible rational roots are plus or minus 1 over 2 over plus or minus 1, 5. Number three. What's the sum of the roots of a polynomial? B. Negative second over the first. Number four, when using plus minus notation, which would not result in a sign change? A quadruple root. Number five, which of the following must be true about a polynomial of degree 5? B, there must be at least one real root. I'll explain that in a minute. Number six, how many negative roots are in that thingy? C, 0. And it repeats 1 through 6. All right, number 7. I'm just going to give a rough sketch of this thing. Identify the holes, intercepts, and asymptotes. There are no holes. There are a few intercepts. This is for number 7. Let me just work it out. X squared minus 5x plus 4 over x squared plus x minus 6, this is y equals. The top factors to x minus 4, x minus 1 by unfoil. The bottom factors by unfoil to x plus 3, x minus 2. Does that make sense? So two numbers that add up to negative 5 and multiply to be positive 4. And then two numbers that add up to 1 and multiply to be negative 6. That should hopefully work. This means that there are roots at x equals 4 and x equals 1, and there are vertical asymptotes, because those are on the bottom, at x equals negative 3 and x equals positive 2. Is everybody okay with that so far? Yeah.
So you find like x minus 4, x minus 1, all that stuff by
Factoring.
factoring.
Right. So you can factor unfoil is the quickest way.
Yeah.
If you get totally desperate on a squared, you can do magic pair. It just takes longer, but it should work. So the graph on this thing should be a root at x equals 1, a root at x equals 4, a vertical asymptote at x equals negative 3, vertical asymptote at x equals positive 2. Now they did ask for holes, there aren't any. Intercepts. We've got the x-intercepts, but there's one other type. You can get a y-intercept. A y-intercept is found by setting x equal to 0. Plug that in and see what happens. You get y equals 4 over negative 6, which is really negative 2/3. Now that's a little hard to graph. Here's negative 1. Make sure you mark this. It's like negative 2/3. But that should give you an idea of what the graph is doing. Now let's do a little bit of detective work here. I have no idea what it's doing to the left. Yeah, question.
So on the actual test, do you want us to find the y-intercept?
If it's useful. Yeah, if it's, well, this one it says find the intercepts. That includes x-intercepts and y-intercepts. So yes, I do. Yeah, so if you don't have the intercept, write in y equals negative 2/3. Yeah, good question. Now, again, I have no idea what's happening on the left. It could be above, it could be below. In the middle, I have a little more info, and on the right, I really don't know. It could be coming from above, it could be coming from below. So there's a lot of mystery here. The middle seems to be what I have the most data on, especially the y-intercept was very helpful. If I go to the left, I know it's hitting a root here at x equals 1. If I go to the left, where's the graph going? Spencer? Which direction does it seem to be going? If you crude to the left.
From the first
From here.
point,
Is it going up or going down?
now down.
Yeah, it has to go down in order to hit this. Could it ever go back up in between here and here? Okay. Could it possibly swoop back up?
No,
Why not?
because there's no root there.
Yeah, that would cause a root that we would have seen already. So that's impossible. Where's the only place it could go?
Keep going down.
Keep going down. It's got to swerve to avoid the asymptote, so it's got to do this. Will, if I go to the right of this root, where could it go?
Up.
It has to go up. Why do you say that?
Because if it went down, it would be a root.
If it went down, it would be another root, yeah. And, well, actually, it might not be, but that would be a what kind of a root if it went back down? Yeah, it'd be a double root. Is it a double root? How would you know if it were a double root in the original formula? Sam? How would you know there'd be a double root at x equals 1? Like, if just looking at the formula, it isn't. But what if it were? How would you recognize it?
Well, x minus 1 would be squared.
Right, x minus 1 would be squared. There would be 2x minus 1s on top. Does that make sense at all? So a single root, it's got to go straight through, straight through. I know it looks like it's swerving. It's actually not. It's kind of going like that. Everybody right so far? So it's not a flatten out and then go back up. That would be a triple root. Straight through would be a single root. Now, can somebody tell me anything at all about where it's going to reappear on the right-hand side? Mary, what do you think? What kind of an asymptote is this, first of all? Single, double, triple? Single. What does the single asymptote do? Do the signs go same direction or opposite direction?
Opposite.
Opposite. So where's this going to reappear?
Below.
Below. And then what's it going to do?
Towards the root.
Yeah, is it going to go straight through, bounce, or swerve?
Straight through.
Straight through. And I have no idea exactly where it's going to go here. Can it go back down?
No,
Why not?
because then it would create another root.
It would create another root, correct. So it's going to go, it might flatten out, I don't know. It might keep going almost straight up, I don't know. It doesn't really matter. As long as it stays up, we're good to go. Here's Claire. On the left-hand side, where does it have to reappear? Above, correct, because it's another single vertical asymptote. And can it go through? No, that would make a root. So it's either going to flatten out or go back up. I'm not sure, but for our purposes, we don't care. And that's the graph. Does that make sense? So there's the graph, and you should also include no holes for the vertical asymptotes at x equals -3, x equals +2. I missed one thing. Oh, and a root, 2 roots at x equals 1 and x equals 4. Everybody good on that? Okay, that was number 7. Number 8, solve the inequality. There are 3 intervals. X belongs to. All of these are round brackets. from negative infinity to negative 6, then union from negative 3 to 2, then union from 3 to infinity. Any repeats on that?
Yeah, can you repeat that?
Yeah, so 3 intervals, x belongs to, and all these are round brackets, from negative infinity to negative 6, then from negative 3 to 2, then from 3 to infinity. Okay. All of them are round brackets, correct. Number 9, and I will warn you, number 9 is going to be worth more than 10 points because there are a huge number of parts to it. Number of total roots, 7. Number of real roots, 7, or 5, or 3, or 1. Number of non-real roots, 0, or 2, or 4, or 6. The number of positive real roots, 6, or 4, or 2, or 0. The number of negative real roots, 1. The possible rational roots, oops, hang on a second. Is that the next one I asked for? Yeah. The possible rational roots are plus or minus 1, comma 6, comma 2, comma 3, and they can be in any order you want. All over plus or minus 1, comma 5. Make sense? Beyond that, the real roots lie somewhere between negative 6 and 6, square brackets. So x belongs to square bracket, negative 6, comma 6, square bracket. So it can include 6, it can include negative 6.
You said that was the number of real roots?
That's the interval on which the real roots lie. The number of real roots is 7 or 5 or 3 or 1
Oh, okay.
from above. Alrighty, the product of the roots, let me just hang on a second. It is 6 over 5. The sum of the roots is 3. They didn't print it, I had to do that in my head. I hope I did it right. Then factor and solve. Let me list all the roots first of all. There's the root they gave you, x equals 3. And another one is x equals 1. X equals negative 1. X equals I. X equals negative I. X equals, I'll write it in simplified form, then there's like 2 other ways I'll accept. The simplified version is I radical 10 over 5 and negative I radical 10 over 5. If you didn't reduce it, it would be the square root of 2/5 times I, plus or minus. Does that make sense? Yeah.
For the product, is it negative 6 over 5 because it's an odd hour?
It's negative 6. Oh, heavens to Murgatroyd. Sorry, I had this. Hang on. There's a smudge on the screen. Okay. Yeah, I thought it was negative 5 in front. Yeah, sorry about that. The product is negative 6 over 5. I thought it was negative 6 over negative 5. Yeah.
For, the, like, radical 10 over the 5, I had the I after. Is that
That's
okay?
perfectly fine. Yeah. As long as the I is not under the square root, you're good to go. Any repeats on number 9? We're not quite done, but so far. Then factoring. I'll accept 2 different versions here. Let me just carry this over. Oh, I'll give myself a whiplash. Let's not start chatting. Okay. First one, f of x or y, I don't care what you call it. The height multiplier is 5. Then there should be 7 parentheses if you fully factored it. There are a couple other options you can do. So it'd be like this: x minus 3, x minus 1, x plus 1, x minus I, x plus I. And I'm going to do the unsimplified form. I'll do the simplified form. X minus radical 10 over 5 times I, and x plus radical 10 over 5 times I. That's one variation. Here's another one you could do. You've got x minus 3, x minus 1, x plus 1. You can also have x squared plus 1, which would take the place of these two. And this thing, I believe it was 5x squared plus 2. So if you have that, I'll also accept that. That's what you'd probably get if you factored by grouping at some point. Any repeats on number 9? All right. Number 10 was just a blank spot for number 9, so don't worry about that. Number 11, extra credit. Construct your own inequality, which would have a solution set of those two intervals. Well, there are lots of possibles. Here's a hint of how to do that. I want to get these intervals to work. I want these to be successful intervals. From negative negative infinity to negative 6, round, and then square bracket 3 to round bracket 5. Okay. There are loads of possibilities here. Do you remember these come from plus minus notation? I know for a fact, if I do plus minus notation on this thing, there have to be at least 3 numbers on the graph. Negative 6, 3, and 5. Do you see that? Does that make sense? Now something interesting is happening at all of these. Do you notice there's one square bracket in here? That tells me something. The original problem has to have either a less than or equal to or greater than or equal to. So it has to be like blah, 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 has to be less than or equal to 0 or greater than or equal to 0. It's totally up to you which one you pick. Just be consistent. I'm going to pick one. Oops, it just occurred to me that that's off screen for the people on the video. All right, so it has to be, the function either has to be less than or equal to 0, or the function has to be greater than or equal to 0 because of this square bracket. The only way you can include endpoints at all is if they ask for it. If your customer wants the root, then you give it to them. And by the way, it has to be a root here. If it's a hole, I wouldn't give it to him, it's lethal. If it's a vertical asymptote, I wouldn't give it to him, it's lethal. So it's got to be a root at 3. So a little detective work paid off. We've got one of our 3 things marked there. Question, could the thingy on 5 be a root? Please.
No,
Why not? You're right.
because it wants to, since it's equal to, it wants to include the roots.
Right. The customer is asking for the roots. And if this is an actual root, you would have seen a square bracket there. So this has to be something else. There are only 2 other options. Yeah.
Vertical asymptote or a hole.
Vertical asymptote or a hole. And you can kind of pick. It'll kind of depend, and there's actually only one of them that would work. Yeah.
It has to be a vertical asymptote.
Why?
Because it would not include 5, but there would still be an interval.
Yeah, pretend this is a hole, like up here. Would there be a sign switch over that hole? No. That means there would be another interval after 3 and 5. It would go 6 to infinity, or 5 to infinity. If this were a positive and they wanted it, this would be the same sign, and you'd also include that. Now, I can think of one other case. Definitely if the vertical asymptote would work. There's one other rare case that would work also. Yeah.
On the X, or the holes on the X-axis.
If we have a hole on the x-axis, correct, on a war. Those are tougher to build. I would just say, call that a vertical asymptote. And they don't want negative 6, so I would call that a vertical asymptote as well. That's the safest thing to do. Now you decide, oh math people. This is actually kind of, people either have fun with these or they get stressed out with these, because you get to pick whichever one you want. This is actually good practice. If you ever become a math teacher and design your own tests, this is exactly what I do to design the test. I choose ahead of time, do I want it to be less than or greater than? Do I want the negative regions or the positives? It's up to me. In this case, it's up to you. So Nate, choose. Would you like the negative regions to be the good answers or the positives?
Negatives.
Negatives. That means that this interval has to be negative, and this interval has to be negative. So that means on the plus minus notation, this has to be negative, and this has to be negative. So, where should the graph be physically to the left of negative 6? Josh? Below. Has to be below. Can it ever come back up? No. Now, if this is the case, can I crash through and follow the asymptote up? Why not? There's no extra x-intercept, and that would also create another positive region. So there's only one choice. This thing has to go down. Now, yeah, question?
Do we have to like graph it?
Do you have to graph it? No, we do not. I just wanted the formula. I'm just trying to reconstruct. Where should this reappear? Above or below? Austin? Say it.
No, sorry, I was just thinking, above,
Why above?
yes.
You're right.
Yeah, because like asymptote, the same asymptote flips.
Right. What kind of asymptote?
Just like a single one.
Correct. It's a single vertical asymptote, which means it's going to switch the sign. That means this has to come from above. What's going to happen next, Shaylee? Where's the graph going to go next?
It'll go through 3,
Is it going to straight through, bounce, or swerve?
3,
Straight through. Correct. And where's it going to go from there?
down.
Down. Follow the asymptote. And then where should it reappear? Abby?
Above.
Above. Why do you say that?
It's a sign switch from vertical asymptote.
Yeah, single vertical asymptote has to switch the sign, and then it comes from above. Should it ever crash down?
No,
No, why not?
because there's no root.
There's no root there, and there's no extra region. So yeah, this thing can go flying off, whatever. But this is what our graph should look like. There's a negative region here, negative region here. By the way, I will accept two possible answers to this. If you get a formula, I didn't say you had to give me the formula. You can give me either the formula or the graph. Your choice. That make sense? I will actually say the graph is faster if you build it correctly. But if you need the formula, I'm actually going to stall on that a little bit because I want to go through the actual, the non-extra credit answers. But if you want to know how to construct the formula, we'll see if we have any time here. Otherwise, I'll see if I can maybe do that on a video. Number 12. Identify the holes, intercepts, horizontal asymptotes. That was a typo. It was supposed to be vertical asymptotes. Sorry. Okay. Where are the holes? None. Where are the intercepts? There are two of them. X equals 0, x equals 1, and the y-intercept is also at y equals 0. It's supposed to say vertical asymptotes. It's supposed to be at x equals 3 and x equals negative 3. And then sketch the graph. It's going to be roughly like this. Yeah, I will fix that for the real. I'm so sorry for that. That was me being dumb. Vertical asymptote at 3, vertical asymptote at negative 3. There's a root at 0, a root at 1. And if you did plus minus notation, it would look like this. It comes from below, quick goes above, quick goes below, ducks back down. And then up here, it's going to come like this. It cannot go below, cannot go below. Question? Yeah, right back. It does not have to be perfect on the left and right. All I know, for all we know, this thing could go back up. That would be okay if you put that in your sketch. Just make sure it doesn't go below 0, because that would make another root. Does that make sense? Because the plus minus notation this would register as positive, this is negative, this teeny one is positive, then negative, then positive. That's the way I found out. I did plus minus notation on it. Okay. All right, any repeats? I'm open to questions. Go for it. If you ask about number 9, you'll have to break it up into individual parts. Yeah,
For 11.
yes.
Could you just do the plus minus notation to figure out which ones are asymptotes and roots and stuff, and then do like.
And then do the actual
the
formula?
fractions where you put like.
Yeah, the formula should look something like this. If you have blah, blah over blah, blah is less than or equal to 0. That's, if you do the formula version, it should look something like that. So the top, actually there should only be one on top, because there's only one root. Can anybody tell me what the top would be? The root, yeah, x minus 3. Correct. Does that make sense? Because that's the only root that was in there. And then 2 vertical asymptotes, I can do, can somebody do those for me? Go.
Be just x plus 6 and then x minus 5.
X plus 6, because that's this one, and x minus 5, okay, this one. Now there's only one little catch. You decided that we wanted the negative thingies. You have to run plus minus notation once, even in one region, because I want to make absolutely sure this negative is actually negative. This positive is actually positive. Here's what I would do. If you want to do your own formula, the only thing I still need to find out is which way do I send this sign? Less than or equal to 0 or greater than or equal to 0? Let's find out. I'm going to test 0. You don't have to plug anything in. Look at the graph. Is 0 plus or is 0 minus? Gordon. Just looking at the graph. Where is the graph at x equals 0? Is it above or below?
0? It's,
It's somewhere in between here and here.
wait, what are you asking? Sorry.
Here's the graph. Is the graph when x is equal to 0, here's 3 and here's negative 6, is the graph above or below 0 when at that very point?
Above.
Above. So when I test this region, it came up positive. Did I want positive regions or no in this problem? Look at the ones I circled. No, I wanted the negative ones. Tell me what I should put. Greater than or equal to 0 or less than or equal to 0? In other words, I tested this region. Do I want this region as part of my answer? No. So how do I make sure that a positive region is bad? What should I put here? Yeah, less than or equal to 0. That makes the negative regions good. Does that make sense? It's a little trickier to do this formula than to do the graph. So I'll leave it up to you, whichever way you want to do. If you do this formula successfully, I might actually add +1 extra credit to that, because it is tougher. We'll see. Next. Any questions on 1 through 6, the multiple choice? Anyone who are trying to figure out how on earth do we get that answer? Yeah, Gordon.
5?
Number 5, yes. What must be true about a polynomial of degree 5? Let's go through the choices. There are 4 choices. First of all, at 5 roots, can somebody tell me, Nate, if you have 5 total roots, give me the possible real roots.
5, 3, 1.
5 or 3 or 1. Could there be 0? No. Can you give me, Abby, the number of possible non-real roots? There are 5 total roots whatsoever.
4, 2, 0.
4, 2, or 0. Look at the choices they add. There must be at least 5 non-real roots. Is that an option? No, because there can only be 4 or 2 or 0. So cross off A. B, there must be at least 1 real root. What are the choices for real root again? Okay. 5 or 3 or 1. Is that true? Choice B. Yes, it is. You just got your answer. But let's just keep going. The number of positive roots always equals 5 minus the number of negative roots. Is that true? Let's just say there's one positive root, then there has to be 4 negative roots. Why not? I see some people shaking their heads. Joe?
Because it's the number of sign changes.
True. Well, let's just say we're guaranteed to have 1 negative root. Is it guaranteed that there will be 4 positive roots as a result?
No.
Why not?
Because there could be imaginaries.
There could be imaginaries, and they always go missing in pairs. And D, it never hits the x-axis. Is that guaranteed? What? No. Why not? What can you say about something that never hits the x-axis ever? What about all of its roots? Yeah,
They're all imaginary?
they're all imaginary. Is that possible?
No.
No, only 4 or 2 or 0. So the only choice that's still alive is 5. B. Make sense? It's a little detective work there. Next. Yeah. Yeah. Go ahead. Any others you want to see? Got 15 minutes, so I could thrash through anything that I can possibly turbo through. Yeah.
So, can you just explain the graph for something again, like
Go which one?
7?
Yeah, absolutely.
It just stuck there.
Yeah, number 7 I went through real fast. Let me do that a little more slowly. Let's go from the very beginning. Boy, it's getting harder to read. So f of x is equal to x squared minus 5x minus 4 on top. Or plus 4. And then the bottom is x squared plus x minus 6. And they want you to graph these things. So they want the holes, they want the vertical asymptotes, they want the roots. Well, actually, all the intercepts. So I'm going to say x-intercepts and the y-intercept. A quick trivia point. Why didn't I put plural for y-intercept? Well,
It can't go back.
correct. Why?
Because,
What's stopping it?
function.
It's if it's a function, it can't loop back and forth, otherwise it'd fail the vertical line test. Yeah, the y-intercept, the y-axis is a vertical line. So you can only have 1 y-intercept ever. You could have 0, but you can have at most 1. So, how do I find out if anything holds vertical asymptotes, blah, blah, blah? How do you discover that? Mary, take over. What would you do first? Yeah, factor. Does it? Go for it.
So it's x minus 4, x minus 1 on top,
How do you get that?
y unfolding here.
Right. Two numbers that add up to -5 multiplied by 4. And then do the bottom formula.
Is x plus 3, x minus 2.
How do you get that?
We can unfold again.
Right. Unfoil, add up to 1, multiply to -6. Does that make sense so far? Everybody? Now, actually, Courtney, take over. Are there any roots? Whereabouts?
4 and 1.
Yep. X equals 4, x equals 1. Do any of these things cancel, by the way? So in other words, there are no whats? There are no holes. Correct. So, Spencer, take over. Are there any vertical asymptotes?
Yes.
Whereabouts?
-3
-3.
and 2.
Correct. And 2. By the way, all of these things, single, double, triple,
Single.
they're all single, every single one of them. Is everybody okay with that? Once you've got it factored, once you've got the ammo, so to speak, can somebody get the y-intercept for me? Sam, how do you get a y-intercept?
When you set x equal to 0.
Right. What do you get?
You get 4 over -6.
Yeah, 4 over -6, which reduces to what?
To -2 over 3.
-2/3. That's your y-intercept. Now let's see if we can reconstruct the graph. So you tell me. Abby, take over. Where, give me some objects to graph.
Vertical asymptotes,
Whereabouts?
-3 and 2.
Good, x equals -3. And x equals 2. So Josh, take over. What other things can we graph?
There's some intercepts.
Yeah, x-intercepts, like what?
There's one at 1,
Uh-huh.
and one at 4.
And 1 and 4. And where's the, whoops, 1, 2, 3, 4. Where's the y-intercept?
-2/3.
-2/3. So it's going to be here. Make sure you make sure you label it. If it's not a whole number, make sure you label it somehow. Is everybody still okay? All right. Now again, if you're lucky, you should have a couple of points that indicate where the graph's going. If you don't, you're not doomed. What I usually do is plus-minus notation on this, which says if it's going up or going down. Does that make sense? I'm gonna do that just to be safe. We got super lucky here with the y-intercept. The y-intercept is going down, which pretty much told me the rest of the whole graph. But let's say it didn't. If all you had is x-intercepts, there's no way to tell if it's coming from above or from below. Same thing here and same thing here. We're sort of flying blind. But I know there are 4 breakpoints. There's -3. Then 1, 2, and 4. The roots are at 1 and 4, I think. The vertical asymptotes are at 2 and -3. So we've got 5 regions, A, B, C, D, E. Tell me what to do next. Nick?
You plugging 0,
Okay, what region is that?
B.
B. So if x is 0, what's y? We got 2 parentheses on top, 2 on the bottom. Plug in a 0.
Negative,
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 positive,
positive.
negative,
How many negatives total?
3,
What does that make?
that's a negative,
That's a negative region. Correct. What about region C?
that is positive,
Positive. Region D?
negative,
Negative. E?
positive,
And A?
positive.
Yeah. If they're all single asymptotes, single roots, it'll always switch the sign. Now, does that help with the graph? Okay. Where would you, what can you possibly do with this? What does it mean?
Section B starts negative.
Section B starts negative, so do I start above or below?
Below,
Has to be below. And then do what?
hit the y-intercept,
Hit the y-intercept?
and then the right,
Bounce, straight through, swerve?
straight
Straight through, because it's single. And then where does it have to go?
up.
Up. Correct. We now have a lot of the graph. If you remember that single vertical asymptotes swerve opposite ways on either side, you can probably finish the graph right now. But, take over Blaze. How about on this side?
Yeah, it comes from the top,
Comes from the top. Tell me why.
'cause it's a single asymptote,
Right, and there's actually another reason.
that's positive.
Region A is positive. Correct, so it's gotta be above. Does it ever go below?
No.
No. So over here, you can do lots of options. You can flatten it out, you can have it go back up. I don't really care. In real life, which is, later on, like in chapter 3, we'll get more specifics as to how you can tell if it goes back up or flattens out. There's something called a horizontal asymptote, which we'll study in chapter 3. That's why the typo was so bad. And then, single vertical asymptote. You can also look at region D, which is between 2 and 4, is negative, so it's gotta come from below. It's gotta go straight through, and that's it. Questions? Does that make sense? Can you recreate that on a test? Next. Any other ones? You got about 7 minutes, so make it good. How do you know number 8? You okay on that one? Any more questions? I'm trying to balance things all. I have recess meetings, so I was like super cold for a month. But I finally warmed up. So I don't need you to die of heat. Let's go to meetings. So any other questions? 1 through 10 doesn't exist, but 1 through 9. Everybody understands the parts of 9? Intervals, possible negative, positive, positive, et cetera, et cetera. Anything else you wanna go over the extra credit? Going once, twice. Right. Sure? Yeah.
Can you briefly just go over
Number 8, let me look. Yes. I will have you help. Can you factor that for me? Let me give you the original one first. Number 8, x squared minus 9 over x squared plus 4x minus 12. And they want this to be greater than 0. By the way, are they asking for the endpoints? No, why does it not? It's not equal to. So there are going to be no square brackets in our answer whatsoever. The customer is not asking for the ends, so we don't need them. So factor it for me if you would. Will, go ahead. Does the top factor? Into what? Right, what method is that? What factoring method? Starts with a D. DI. DIF? Difference of 2 squares, there you go. Bottom. Katie, take over. Factor the bottom for me.
So it'd be,
X and X.
X plus 6.
Yes.
Minus 6.
What technique was that?
Okay.
On FOIL. So notice it added to 4 and multiplied by negative 12. Now, can anybody spot any objects? Sam?
There's, roots of 3 and negative.
Okay, so roots of 3 and negative 3. X equals 3, x equals negative 3. Keep going.
And then sort of class and total of negative 6 and positive 2.
Yeah, x equals negative 6, x equals positive 2. How would you solve this thing? What would you use?
Would you set them all equal to 0?
Well, you just did, in order to get them. So what would you do with them, now that you have 2 roots and 2 vertical asymptotes?
Oh, do
So
plus
what?
minus then.
Plus minus notation, correct. So I'm gonna do a number line and mark all of these breakpoints in order. Negative 6, negative 3, 2, and 3, and they don't have to be spaced wonderfully. Vertical asymptote at negative 6, vertical asymptote at 2, root, bless you. So region A, B, C, D, E. So we'll take over from here. What do you do now? Plug a number in. What's a nice number? 0. What region is that? It's region C. If x equals 0, how do you find y?
You plug in 0 for x, right?
Good. And there will be 4 slots. Go for it.
So positive,
Positive, negative, positive.
positive,
So what does that mean?
positive,
It makes total positive. So region C is positive. How about region D?
negative,
Yes. E, positive, B, and A. Good. Any single root or single vertical asymptote is going to switch the sign. Double does not, triple does, and so on. So what regions, Spencer, take over. What regions are going to solve this problem? Here's the original problem. What regions are they interested in? The positives or the negatives? Second? I'll give you a hint. What kind of numbers are greater than 0?
Positive.
Yeah, that's the difficulty. They want the positives. So they want region A, region C, region E. Give those to me in interval notation if you would. X belongs to what?
Oh, negative is
Yep.
negative 6.
So negative 6. Do I do a square bracket or no?
No.
No, vertical asymptote, unsafe. Then union
Negative 3, 2.
to 2. Do I include negative 3?
Yes.
I would love to.
Oh, it's not. I saw the dot.
A root is safe.
Excited.
You're right, normally I would. But
Oh,
the customer
yeah.
is not asking for it.
So no, you do not.
Correct, and do I include two?
No.
No, because that's an asymptote, they die. Union, one more.
3 in infinity.
3 to infinity, do I include 3?
No,
Why not?
because it does not ask.
They didn't ask for it. It's safe to include, they didn't ask for it, and that is your answer. Questions? Feeling okay on this? The real test should look hauntingly like this, I just changed the numbers. So if you're good on this one, you're good on the test. There should be plenty of time to take the test also tomorrow. Don't dawdle, but you needn't panic, and look over your answers. If you have time, do some double checking, try an extra credit problem, et cetera, et cetera. That is about all I have for you. I don't think we could have timed that better if we tried. Please stand. Let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Hail and blessed be the hour and moment in which the Son of God was born of the most pure Virgin Mary. At midnight in Bethlehem, in piercing cold. In that hour, vouchsafe, O my God, to hear my prayer and grant my desires, through the merits of our Savior, Jesus Christ, and of his blessed Mother. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Somebody hit the little record. You think